So let's talk about data. So data has been labeled as the new oil. That's been around for quite some time. What is it about data that makes it such an exciting and important commodity?
I guess it's what you can do with it, right? So like oil, you can refine it and transform it into products, right? You can make plastic bags or fuel out of oil. Out of data, you can make insights, and based on those insights, you can make decisions. Now, unlike oil, data is infinitely reusable. It's an ultimate renewable resource, right? So once you extract it, refine it, transform it, and store it, you can keep coming back to it and keep asking it different questions. And that is why it's important, and why people should pay attention to how they treat it.
You know, sort of touching on that piece where you speak about, you know, you can renew data. It can be recycled multiple times. Can you share any examples, you know, where maybe you saw this in action? You know, where this data was refined, you know, to actually provide some of those new insights?
Okay, well, one of the examples comes to my mind is a project I was involved in some years ago. This was a supply chain optimization problem we had at one of the iron ore producers over in the Western Australia. And the challenge we set out to achieve was to be able to berth one more ship per 24-hour period. So the data that was there was things like tides. So tides wait on no man, as the saying goes, but things like market price for the iron ore at the time, and contract prices and spot prices, availability of the loading equipment, typical patterns of downtime, and so on and so forth. All of the data was available to human schedulers. But the challenge was to get more out of the system, so to speak, right? So yeah, that was a complicated project, and we did that some years ago, before AI and large language models were cool. Just to give you a perspective and a context of the gravity of the decision, right? So an average small bulk carrier is 65,000 tons of cargo. At $100 per ton, that's about 6.5 million bucks. The big ones go to 200 tons. So you can do the maths. So that's the gravity of the decision you are making there, whether you're going to be able to berth that ship or not. When I say human element, we of course had very experienced human schedulers that you know have been doing this for years, and at the time they told us it cannot be done. And it took a little bit of doing to actually show them and convince them that the model is right, because ultimately they had to make the decision to schedule that ship in. There are penalties involved in scheduling the ship in and then not being able to load it, right? That's all part of the constraints of the model that we had to build. So we actually had to take them on a journey of how the model works and show them the variables that are taken into account into each decision. And there's a decision tree to it, right? So at each step of the way, the model would kind of explain itself why it's suggesting a particular decision to be made or not. Yeah, and that did the trick at the time.
Yeah. So I mean, I suppose in that example there, it also demonstrates that when you are making use of your data, the efficiency gains.
That can be staggering, right? So
it can be staggering, even though it was one more ship. It doesn't sound like a lot, but when you really look at it, it's a major impact. And I suppose it wasn't only a productivity output. There can be around that same data that was available, other areas. It could reduce maybe even waste, because your scheduling time has been ultimately optimized. So I suppose there's more than one gain that you are also touching on there.
Sure. I mean, there's of course the performance of the company. Different example. I can't take any credit for this one, but Rio Tinto's been running with autonomous haulage for quite some time now, right?
Yes.
Same data, same track, same open pit, and you know the autonomous systems are able to get 700 hours per track of more runtime. And you know, because they're easy on the clutch or whatever it is that they do differently, the maintenance costs are down by 15% as well. So, and those tracks are big, expensive pieces of machinery.
No, look, and thanks for sharing that particular example. But I mean, again, if we just touch on your experience there, what are some of the key difficulties organizations encounter when starting their data journey, and what best practices can help them really navigate these challenges?
So I often like to start with the why. Yeah? So when we talk about the data and the need to collect it, I think the first question you got to ask yourself is why. Why am I collecting this? What business problem am I going to solve with it, right? So once you get over that and you're clear in your head about what you're trying to achieve, you look at things like quality of the data, and that there's a couple of different variables into that. There is things like confidentiality, we can elaborate on that, integrity and availability of the data. You look at the technology that needs to be applied to this. You look at the organizational capability to actually consume it. You look at the ways to monetize it. And lastly, you look at how to keep yourself safe. So what I mean by this is there's two things. One is cybersecurity, and I won't talk about that. It's a well understood topic. And the other one is about ethical use of data. Yeah. So again, when we're talking about time series data and in an operational environment, that may not be the first thing that comes to mind, right? But when we start talking about some of the availability biases and cognitive biases that are built into the large language models, the ethical use of data comes into that. So that as an organization, you're potentially exposing yourself to litigation. Should you use the data and arrive at an outcome that a human wouldn't, right, under normal circumstances. So these are the sort of key elements of a data strategy you need to think about when you're embarking on that. There's deeper meanings to some of those, in particular around the organizational capability, because that goes to your ability to accept data and make decisions on it and potentially change your business model.
And I suppose that's what makes this topic interesting. I mean, is it a case of just junk in, junk out? Where do you see this having to head? So that we could operate in I suppose a more optimized fashion, especially around the use of AI. I mean, these days pretty much everything comes with AI, right?
I think it's a little bit more nuanced than garbage in, garbage out. That still applies, but because there's so much processing of this and I spoke about the biases, that adds an extra level of complexity for me, right? So the availability bias basically means that the results that are generated will likely be more skewed towards a representative sample of the data that was available for training. Okay? So as an example of how that can go wrong, there was a health organization in the United States which used AI to help with diagnosis of illnesses. And because the model was trained on largely white samples, white people's population, the model was found to underdiagnose or misdiagnose, sicknesses in African Americans, right? So bad outcome for them. Yeah, They might have saved some doctors' time, but that's not what a health organization's for. Yeah, so that's an example of an availability bias.
So I suppose we're just not there yet. There's a lot more learning that we need to do about AI itself.
I personally, I think it's fascinating. I mean, I still find this amazing what those models are capable of, right? And the challenge I have, and I'm not a mathematician or a statistician, and I have a very superficial knowledge of the topic, is that we don't actually know how they work, really. So there was an experiment run in MIT, again, somewhere in the States, I think, where they attempted to teach the model, large language model, so not a computational model, not Deep Blue, which won, a chess game with Kasparov 20 years ago or more. They attempted to teach that model how to add up numbers, okay? And the researchers were failing in that, and they provided a whole heap of data sets because it's essentially spoken language. They left the model running overnight unknowingly, right? And when they came back the next day, and they were failing. The model wasn't able to add up reliably to numbers. You could say, what's 2 plus 2? And it would come up with something. And you said, no, I think it's 5. Okay, it's 5. Yeah. Eventually, when they come back the next day, the model learned to add up the numbers correctly, but it also learned to do it in French, which is something they didn't ask for.
So a bit of French bias.
Yeah, call it what you want. It freaks me out because nobody actually knows how this thing works.
Wow, that is that is fascinating. That is a great fascination. So I mean, in terms of let's touch on organizations, culture around data. What role does organizational culture play in the success of data-driven, decision making or transformation?
So I would extend this to, again, asking the why question, right? So be clear about what and why you're collecting, and then have the appropriate data governance in place. Okay, so this sounds a little bit boring, I get that, but it's part of the culture because other than the details of how you're going to capture, collect, transform, store the data, it also talks about things like compliance with appropriate acts around privacy, storage. It talks about ownership of the data, and I think that's an element that's often missed, right? So, okay, great, I've put a sensor on something that I think is important, job done, but who owns that piece of data that's then going to travel, via PLC into a historian and then eventually into some online data platform, right? Who owns that piece of data? Who's responsible for calibrating that sensor, and who's responsible for ensuring integrity of that piece of data, that it's not manipulated along its way to that online platform, and so on and so forth. So that's a broad understanding of the culture. And then the next piece for me is the data-driven decisions culture, right? So it's, as managers and leaders, we rely on gut a lot, on gut feel. It takes some guts to pull yourself back from that and go, what does the data tell me? How can I support this gut feel with my data, right? And again, human biases come into that, cognitive biases around, people will seek out data that supports what they already think is the right outcome, right? So it takes some discipline to extract yourself from just going with your gut and then finding bits and pieces of data that support that. Yeah?
I suppose here a question, what mindset along with methodologies should organizations adopt to be able to really test and validate their data to harness some of those new insights?
Look, in terms of methodologies, I'll come back to the sort of 5 key elements of the data strategy, right? Data quality. Think about how you're going to monetize this. Think about your organizational capability. Think about the tech. Let me talk about the tech for a little moment because we haven't spoken about that. And the idea of proofs of concept is one of my pet peeves, the proofs of concept. People like to do proofs of concept. The very first question I ask when they come to me with that, I say, what are you proving? What is your hypothesis? And how are you going to know you finished? The other pitfall in the proofs of concept is not setting a time limit, right? So if something can be proven, you need to put a time boundary around it, right? Otherwise, you risk just bleeding money and resources and attention to something that's just bubbling away. Not establishing a commitment across the organization. So, proofs of concept have a tendency to fly under the radar in terms of the corporate governance around investments because they sometimes free because the vendor wants to do something. And even if it's paid, it's often under a certain delegation of authority. So, but you do need to talk to your execs about, hey, we're doing this. If this works, we actually want to look at expanding it, finding a next use case, maybe implementing it, right? So you need to talk about it. Don't treat it like black ops and hope for the best. The other one is not treating this as a proper project. And this is my background comes out here. I spend a lot of my time running projects, so I know that usually gets you the outcome, right? When you have a timeline, you have a scope and a budget, whatever that is, and you deliver to that, that still applies to running a proof of concept. And the last one for me is not being clear about what we're going to do after. Okay, so linking back to your hypothesis, so we've set out to prove something, we have, so now what? Are we ready for the next step, right? And that's a little bit where the technology comes in, right? So when you're setting out to do a proof of concept, you actually need to think about the tech. Even though it's a proof of concept and it's sticky tape and blue tack, you need to think about how you're going to scale it and whether that's going to be reliable, right? A great example here, and the one that I like, is Amazon has introduced just walkout shops in the States. And the idea was that you come in, you log in with your Amazon account through NFC or some other method, and you pick up your groceries and you walk out. And then Amazon figures out what you took and then charges your Amazon Prime account or whatever. So that was all working great until it came to light that the AI employed behind this was actually approximately 1,000 humans in India analyzing hours of video from the store and then charging your account manually. So that's an example of not thinking about the scale or reliability of a proof of concept.
Yeah, I see. So we talk about data being the new oil. What do you see as pure organizational challenges that just stand in the way?
Not looking at it as an asset. So assets are valued. There's an Australian Bureau of Statistics paper that I found, which I read when I have trouble sleeping, about how to value data as an asset. They haven't come up really with a good answer, and it came down to you basically value the cost of acquisition of data. But when you start thinking about data as an asset, you will have a different mindset about it, right? Because you want to get value out of your assets. There's a return on assets. So that could be one line answer, not thinking about data as a valuable asset.
So if you were going to just maybe summarize some of our question and answer session here today, how can organizations make the best start around their data?
Yeah, look, I think doing something like data inventory is not a bad place to start, because we collectively collect a lot of data already. Every operational technology environment I've worked in is brimming with data, right? So a good place to start is to actually figure out what you already have, and then determine what out of that is just making sure your process doesn't explode in your face, and what out of that can be used for some strategic insights. Once you narrow that down, you can then think about some more structured data strategy, which we discussed earlier, and then look to derive insights and make decisions based on that. So that's where I would start.
No, excellent. Well, look, thanks, Jack, for sharing some of your insights today. It's been great to have a conversation around this. I know it's a complex topic. Sometimes we struggle with where to start, how to start, but some of the insights that you've shared there maybe also just point us into a bit of a direction of where we could get started. So just in closing, data, much like oil in the industrial age, has become the lifeblood of modern enterprises. It is propelling innovation, efficiency, as well as competitiveness, and it's really emphasizing how data has transitioned from a byproduct of operations to really a foundational element of strategic decision making. So thanks, Jack, for joining us.
Thank you, Craig.